Hello. So Dr. Kaminsky already said kind of what EPO does, which is good. The name kind of gives that away, education and public outreach. The entire idea of the Education Public Outreach group is to further people's interest and ability to get into STEM careers, and by careers I mean both going the academic path and actually working on site in places, which is part of the point of this one. I'm going to say my summary because I don't remember what slide I did next. So the Rising Data Program is a class that we put together. It goes to California community colleges, specifically in the grant it's specified Hispanic serving California community colleges. There might be more than a name, but that's the idea. We're starting with 5 of them, moving on to 10. We give them some hardware to build up so they can basically build their own scientific experiments that can be flown in the air and get aerial data on something. So they can use either a rocket or an unmanned aircraft to do this. And now I'll see what this next slide is. Oh, okay, it's this. So this is what I already said. These are the unmanned aircraft, the unmanned aerial systems, as they are now officially called, that we give them kits for. They build them up. We'll talk about what the scientific payloads are in a minute. And that's one of the rockets, which I'll also talk about a little bit more. They send them up, they get data, and the rockets in particular look like this. So, we got sound.
No, we want the sound.
Oh, you want to
Let me see right there. All right, so that's a really important part. All right, so the idea of how you gather data with rockets. These are fairly small ones. We did the small ones because you don't have to worry about licensing issues. They get big, like bigger than people, giant rockets. They go up in the air. They have some sort of combustible motor that pushes them up as high as you want them to go. There's a small charge, usually, in the cone that will separate the rocket into pieces, which you can sort of see if you squint here. The main body you don't need anymore. It was just to get up in the air. It's going to fall down on its own. The payload that's actually catching data is going to come down usually as slowly as you can get it to on some sort of parachute. So you can see a little bit of a parachute here that is going to let that payload that has the sensors on it slowly drift down. And I'll talk a little bit more about exactly what that does momentarily. The general goals of the project are in line with the goals I already stated for education public outreach altogether, which includes increasing STEM retention among underserved students, and I'll specify that a lot of the write-ups in the grant are focused on. Part of the problem is that people don't know about science and engineering career paths and they never get started. Another part of the problem is that if they do get started, they don't finish. A lot of people, especially low-income and minority students, never end up finishing their degree, or they switch to something else entirely. And there are a lot of reasons for that. One of the things that the research has shown is that a lack of engagement among these groups is a big part of it, because they're coming into something, usually they're first generation students, they don't have a lot of connections, so they don't necessarily feel like they're part of this community. But giving them something like what we're all doing here, the research opportunities, that tends to engage, taught them about the actual aerial systems, how to fly. We had some nice talks about the legal issues where drones get involved, which was worse at this time than it is now. Gathered some data to demonstrate how everything worked to people, and since then we've distributed materials so they can actually teach the course, which they are, actually I guess they're done now, but they had just taught this last semester. So we had 5 classes going to different schools, and we're going to see how that went and move forward. All right, so the hardware that we sent them, this is the main contribution that Sonoma State made. So the Protoboard is partly based on things that we've used before. EPO did have rocket-based programs before that I helped with a bit when I first got here. This is smaller than anything we've used before, very efficient, and able to be used on very small aircraft that, again, have low cost of entry and don't have any regulatory issues you have to worry about, or at least not very many. So we designed this essentially to interface with an Arduino Trinket microcontroller, which is a commercial off-the-shelf product, as well as other commercial sensors that can be hooked up to here. We provide a couple that I'll talk about, but it's modular. People can put in other sensors and develop their own experiments as they see fit, and especially when we make this more available, other teachers can take it and do whatever they want with it. We do set it up for them so that they can hook it up with an SD card and get all of the raw data written as they go in real time and have all that to read afterwards. We also had to set them up with rockets, which, thanks to Dr. Kaminsky, our department has an extensive amount of experience in, and has a lot of contacts that helped us with this. So we designed another off-the-shelf kit that we were able to do some very slight modifications on to get things to fit. And you can see here, this is, I'll talk about in a minute, what the payload ends up looking like. It has, the top board is the sensor, and the bottom board is the power distribution. And then we have these things on the end I'll talk about that allow it to fit into the little cargo bay perfectly. And you can see the split as well. This is after the charge goes off. This would separate out, and this is where the parachute would be attached to the rocket body. All right, so this is one of the sensors that we send. A 9-degree of freedom sensor. It's another commercial product. We try to do a lot of commercial products because then people can buy them on their own. It's simpler. It can be made available to a lot more people, and it tends to reduce costs. So it has a gyroscope, accelerometer, and magnetometer so that it can basically detect what direction it's going, how fast it's going that way, and the rate of change of all of its movements. So you can track a flight. If you're launching a rocket, you can see on that graph where it hits apogee, where it starts to come down. You can see how fast it's doing all of those things. And again, you can replace it with a wide range of other options. We do also have temperature sensors that get linked in as well, so you can get temperature readings at different altitudes. And then anything beyond that, they're welcome to hook up on their own. So this is what the data would look like with that 9-degree freedom sensor. So here it's separated out into the X, Y, and Z components of the different sensors themselves. You can also combine those in different ways. Right now we're having them just load data into Excel pretty much and graph it and look at it in that sense. There are other possibilities for data analysis, but this is the most hands-on and very realistic approach to how people do things. All right. So moving forward, we need to continue to evaluate how things are going, figure out how everything went. In July, we will be meeting up with teachers again. And this is going to be more teachers. We're going to be expanding out to 10 classes running the Rising Data program at this point. We'll be retraining people and training new people, making sure everyone's on the same page with it, as well as getting our assessment data and figuring out what we can improve moving forward. And then we'll get them all of the new stuff, all the new curriculum fixed with whatever the problems were. Long term, so this is the way this works for all these programs, is you have the pilot program. That's where we are now, where you design it and you run it for usually 1 or 2 years, and you get all of your data and you perfect it. Once it's perfected, then you can put it out to the masses. We are NASA funded and government funded on everything, so the expectation is that the work we do will be available, which is why all this is intended to be open source at the end. So we'll provide all of the information people need to make those boards, to put the sensors together, to buy the right stuff. If they don't want to use our stuff, that's fine. They can adapt our curriculum as they see fit. But we finish the pilot program, so after next semester, when we have all of our information, then we can link it together as well as tell people how it actually helped. And that's a little bit about what this part is about. So how it helped and how you measure that. It is inherently difficult with an educational outreach program to measure success. The reason for that is that thing I said in the beginning of what one of the problems are, is that people don't finish their degrees. If you want to have data points to tell you whether or not your program helped people finish their degrees, you have to wait until they've gone through an entire degree program. And by the time someone finishes their degree program, usually the program that you were originally assessing data for is kind of moving on at that point. So there's a little bit of fluidity with the information. There are surveys that get you very direct information. So this is a little sample of what it looks like right now. The current students were given an online survey that basically asked them what they thought about the course, what they think could be improved. And in this case of the question I pulled, assesses how it may have changed their ideas of STEM careers, their interest in science, whether or not it changed if they think science is a boring thing they have to do as a prereq versus something they could do for a career. And hopefully we had some people actually move on to this next step of feeling comfortable with it. And this is all done externally. The group is West Ed that we work with that does that so that we can avoid any bias in doing it ourselves. And that is the end of my presentation, which brings me to some simple acknowledgments, including the actual grant there, the NASA MIRUP grant with a number to go with it, thanks to the Education Public Outreach Group and Dr. Lynn Kaminsky. And we have some logos. NASA, of course, did our funding. Education Public Outreach, Sonoma State University. Not listed are the myriad of other partners we had, Fresno State, Napa Valley, and others that I'm sure I'm not mentioning here. And that is my presentation.
Do we have any questions